days of 1967 held great promise. The future looked bright, and the achievements of the past years seemed to confirm that we would realize our most ambitious dreams. So much had been done in so short a time. Missiles had reached the stage of near perfection in reliability. Satellites had given us new dimensions in knowledge and technology. And the Gemini program, putting 2 men in space to live and work for extended periods of time, had drawn to a successful close in November of 1966. The Gemini blockhouse at Launch Complex 19, that was for 2 years the stage for so much concentrated human effort, was now an emptied shell. The Gemini mission was over. The straight pathway of the past was now behind us, and we would move step by step ahead to the challenges of the future. Ahead to Project Apollo, to send man to the moon. Then at 6:31 p.m. on January 27th, 3 astronauts training for their first Apollo flight were lost in an accident. During a full-scale simulation of their mission, astronauts Virgil I. Grissom, Ed White, and Roger Chaffee died in a flash fire. In the weeks that followed, an intensive investigation sought to find the cause of the disaster and prevent its repetition. The program itself suffered a delay while the changes recommended were implemented, and Apollo again began to look at its goal, the moon. Not too long ago, the wealth of man's knowledge and experience could only be recorded and stored in written form. His thoughts and discoveries, his culture and civilization could only be preserved and conveyed by the bridge of language. Too often his message was distorted, even lost by the limitations of language, the barriers of distance and time. Then came the electronic age and the advent of an era that would change man and his world more in one generation than in all the centuries of recorded history. Global instant communication became a reality. The face of a glass tube became a window on the world. What was happening in Boston or Paris, Moscow or Tokyo, could be seen and heard instantly the world over via satellite.
You can very well imagine what it will mean in our lives when you can sit in your home here in London and witness history as it actually happens, not days or even hours later, but at the very instant it takes place, no matter where in the world.
At Cape Kennedy during the first quarter of 1967, 2 highly sophisticated communication satellites were placed in orbit. The satellites, called Intelsat 1 and 2, joined with other successful and operating communications payloads serving Europe, Africa, Asia, and the Western Hemisphere. Essentially, these satellites performed as relay stations, whirling at an altitude where they appeared to hover over the same point on Earth. These satellites would augment the family of communication satellites now in orbit for receiving, amplifying, and retransmitting radio, telephone, and television communications on a global scale. In this new age, man will be awakened to a new learning about his world and his time, and more important, about himself. During the same period at Cape Kennedy, the Air Force's Titan 3C was assigned the mission of placing 8 satellites into orbit for the purpose of providing a worldwide network for military communications among bases around the world. This group of 8 satellites would be put into a near-synchronous equatorial orbit to augment 7 such satellites already strung out around the globe. These satellites circling the Earth help serve the unique and vital needs of military communications. A few short years ago, the idea of putting 8 satellites into the same orbit as 7 others, using 1 booster each time, would have been considered technically impossible. But the Air Force Titan 3C proved equal to the task. At Cape Kennedy, the Titan core was moved from the vertical integration building to the solid motor assembly building, where 2 solid propellant boosters were strapped to its side. Then the assembled Titan 3C was transferred from the solid motor assembly building to its launch pad. The count on America's most powerful rocket moved towards 0. Data acquired over the Air Force's global network confirmed that all 8 satellites were properly dispersed in orbit and operational. This highly sophisticated mission had been successful. These communication satellites will help bring the people of this planet closer together. The planet which is in turn in orbit around its nearest star, the Sun, the pivotal source in space of all life as we know it. The Sun is the center of our solar system. It has given us light, warmth, food. In centuries past, man has worshipped the Sun. But it can be deadly, too. It can kill. It can change the shape of continents. And it can be capricious and make communications difficult, not to mention frustrating. Before man can leave the protective insulation of his Earth's atmosphere, he must know more about the Sun and how to live with it in the alien vastness of space. To learn more, an observatory was sent into space. It was NASA's Orbiting Solar Observatory, a satellite whose purpose was to add to our knowledge of solar physics. The satellite would conduct 9 experiments, transmitting information back to Earth. This OSO would be the 3rd in a series of 8 satellites to observe and report on the Sun's 11-year cycle of rise and decline of solar activity, a study of major scientific importance for years to come. In the vital area of national defense, the development, refinement, and testing of missiles continued. As part of the Navy's Polaris program, the nuclear submarine Mariano G. Vallejo put out to sea from Cape Kennedy's harbor to complete a successful checkout of missile, submarine, and crew performance.
7, 6, 5, 4, 3, 2.
The test took place at night, and all objectives were fully satisfied. The Mariano G. Vallejo would now join the growing fleet of operational Polaris nuclear submarines patrolling the high seas for this nation's security against aggression. In the first quarter of 1967, 2 other Polaris missiles were tested, but from a pad at Cape Kennedy instead of a submarine. The purpose of the land-based firings was to further improve missile performance and control systems before advanced testing at sea. Both test missions were accomplished, and further data was added to the continually growing technology of missile development. That which is good today must be made better for tomorrow. Improvements are made and the search for higher reliability and better performance goes on. This, it could be said, is almost the history of the Air Force's Minuteman ICBM. Although this dependable missile is already widely dispersed in underground silos in the western United States and is now a positive, massive answer to the threat of aggression, it is still being test-fired at Cape Kennedy. Newer components, materials, and design concepts are being tested on every mission. From successful developments and applications, from new techniques and discoveries, our national defense grows more secure.
6, 5, -4 mark. 3, 2, 1, 0.
Two Minuteman missiles were launched between January and March of 1967, the 16th and 17th successes in a row for this series of tests. The mission: send a spacecraft to orbit the moon, take pictures of the lunar terrain, then transmit the pictures back to Earth. This was the job of Lunar Orbiter 3, to continue the studies of the moon's surface made by Ranger, Surveyor, and 2 other earlier lunar orbiter flights, all programmed to support the Apollo manned lunar landings of the near future, and in addition to expand our resources of scientific data on the moon itself. The spacecraft was, like its predecessors, a complex photographic production unit with 2 cameras, a film processing laboratory, and a system that electronically scanned the film image and then transmitted the pictures back to Earth. The spacecraft was so well insulated that exposure to the intense sunlight in space could be tolerated indefinitely. These photographs were sent back by Lunar Orbiter 3. The moon that we have known and seen from afar for centuries past now waits for man to touch its surface. This will come soon, and then the human mind will bring back to us what no scientific instrument, however complicated, can reveal. satellites had given us new dimensions in knowledge and technology, and the Gemini program, putting 2 men in space to live and work for extended periods of time, had drawn to a successful close in November of 1966. The Gemini blockhouse at Launch Complex 19, that was for 2 years the stage for so much At Cape Kennedy, the first days of 1967 held great promise. The future looked bright, and the achievements of the past years seemed to confirm that we would realize our most ambitious dreams. So much had been done in so short a time. Missiles had reached the stage of near perfection in reliability. Concentrated human effort was now an emptied shell. The Gemini mission was over. The straight pathway of the past was now behind us, and we would move step by step ahead to the challenges of the future. Ahead to Project Apollo, to send man to the moon. Then at 6:31 p.m. on January 27th, 3 astronauts training for their first Apollo flight were lost in an accident. During a full-scale simulation of their mission, astronauts Virgil I. Grissom, Ed White, and Roger Chaffee died in a flash fire.